Well, does anyone have a headache from all that reading?
I was hoping one of us would have understood it to explain it to the balance.
Well, that's Bob's job.
No, that is such a complex. Talking about complexity theory, that is such a yeah. That is such a rabbit hole to go down. How are you, James?
Good.
Hello, Joe.
I'm glad to see we'll all look alert and aware today. That's good.
Alert and alive.
Well, here, James is here, so he can explain it all to us. But you have to simplify complexity so we can understand.
Well, I've been studying chaos theory for a long time, ever since it was made such a big deal out of in the movie Jurassic Park. And I thought, well, actually, in a way, I first started thinking about it when I read the first of the Foundation series, Isaac Asimov, and his whole idea that this guy, this psycho historian, could predict the future using a certain mathematical formula. And then, of course, one of these emergent thingies that we read about recently happened in the form of somebody called the mule that Selden's math had not predicted. In other words, a complex or chaotic introduction from outside the known system. And of course, the mule makes a big mess of things, but eventually they redo the math and get things back in order. So I've been fiddling around with chaos theory and now the relatively new discipline of complex systems for what, 30, 40 years. And I've never understood the math. I don't get much beyond algebra, but I'd always dismissed both chaos theory and complexity theory as simply an indication that they were sort of God. Those two concepts represented all the things we didn't know. But having done the reading, thank goodness, that bit of ignorance has been dispelled. It seems to me they're much more than that. I would like to throw out the proposition that we live in a deterministic universe that includes chaos, complexity, and emergent factors. Just throw that out for discussion.
What is deterministic mean?
Deterministic means everything is predictable because since the Big Bang occurred, you can trace back everything to the movement of atoms.
Now, the quantum guys are saying that more strongly than the conventional physicists, that when you get to the quantum level, this deterministic, this follows that, is, they say, more powerful, the logic is stronger.
Right. And what I'm suggesting for discussion is that determinism ultimately is the rule of the universe, but that within that system there are ambiguities, complexities, and emergent things that appear to come from outside the system.
And of course, as soon as you're talking about determinism, it's hard to avoid the old free will versus deterministic argument.
But you see, free will can exist in a deterministic system just like chaos can, because the very fact that we believe that we have free will is part of the causal chain.
Sure.
Okay. So I'm not saying that's the way it is. I'm saying that's the way
That's
it
the
helps.
argument. I understand the argument. This is an argument that I have heard for 60 years since my first philosophy class in college, and probably another 10 years before reading all this sci-fi stuff.
Sounds like you don't like the idea.
Well, the problem with it is that, I still have this bad idea of agency, and my bad idea of agency is supported by me having ideas and doing stuff.
Right. And I'm very proud of you for still feeling that way. It takes courage and mental strength to still feel that way. I'm proud of you.
Well, while you may be proud of me at another level, I see that as my biggest barrier in spiritual practice.
There you go.
But it gets complicated.
You have support in our reading. The author who wrote in space.com, he starts out by saying chaos theory proves that the universe is not deterministic. But when you get to the end, he says, we don't fully understand the nature of strange attractors. These chaotic systems be, in some sense, deterministic and predictable, but that's yet to be figured out. So for now, we'll just settle for our weekend weather forecast.
Well, it's almost like applying a Heisenberg principle to our behaviors.
Right. And
you can do a probabilistic determination, but that doesn't necessarily equate to a singular person.
So when I go out for my morning walk, it's a Heisenberg walk, huh? Unless I take the same path.
Well, the question is, are you walking or aren't you walking?
Well,
nobody's opened the lid.
Now, let's don't get that deep. Now, one other thing that amused me for a long time that I think is kind of in here is this catastrophe theory, which maybe is a subset of chaos theory. And the thing I particularly liked about catastrophe theory was the model of change, where something goes spiraling up and up and up, and then finally over the edge. Oh, shit.
That's a subset of the lemming theory, right?
Okay. If you have more of them, yes.
Yes.
The other thing that struck me is that complexity science kind of bridged the gap or opened the gap from steady state systems analysis to open-ended systems analysis.
Right, and I think that's an important comment.
Yeah, the beauty to me of now that I understand it better of complexity theories is that it forces you to understand, for example, what a mosaic is. Well, every time I see a mosaic now, I'm going to think it's a complex system. If you take it apart into individual pieces, you will never understand what it was.
Right.
And that's inarguable. So it's the beauty of these sessions for me and the readings is that they open up so much territory that I thought I'd explored before, but really haven't. It's just a lot of fun.
Yeah, it's great to know when you don't know something you thought you knew.
And even more fun to find out there's so much more
Oh, that's the way it is.
Don't
You
know.
open the door, and there's all this stuff.
Yeah, yeah, it's wonderful.
Uh-huh. I think some people have called this our fractal universe.
That sounds familiar. I think I read about something like that recently.
Yeah, we can tag in nonlinear thought along with non-Euclidean geometry
Okay.
as we get into the fractals.
Well, somebody's getting perilously close to using dirty language. It's called mathematics, but I'll hang in there.
I'm afraid that the math is way beyond me these days.
Right,
I
right.
don't think I ever had it.
I know I will never have it. This is a case where I have to hope for that the Buddhists were right, and I have another incarnation to catch up on it.
Well,
Yeah,
incarnation,
even
of course, in Heidelberg is, at least in Heidelberg, you know you got a cat. When you get reincarnated, you just don't know.
Right, right. That's the problem. Now, one
Well,
of
the
the
problem is though, in that entanglement, you don't know which way the cat's going,
uh-huh.
or it's going both ways.
Now, for me, the one problem I have in this whole area of emergence is the thing that has concerned me for at least 30 years, which is what is consciousness? Because the materialist view is that consciousness is something that emerges. You take a bunch of unconscious stuff, smush it together, and then it gets smart. And is this other school of thought that says consciousness is just a property of the universe. And some of the things in my mind that support that idea are the fact that you can have like jellyfish that have learned behavior and awareness and all of that stuff, except jellyfish don't have a brain or a
But they
nervous
do.
system.
They do. Jellyfish, they've discovered, have a dispersed brain. They have a dispersed nervous structure that isn't a lump like ours, but rather is, they've actually tracked the neuronal function, and they've discovered it does have a brain. It's just not localized.
Mm-hmm. Now, I remember in high school biology watching paramecium through a microscope, and they were going around and bumping into stuff and then changing directions. So
Yeah.
it seemed like there was some kind of awareness.
Well, you could see that kind of behavior at any football tailgate, right?
Now, we were talking about intelligence, not football.
Oh, okay. Good point. Hello, greetings.
So what do you think of this whole mess, Joyce?
I think it's really a lot to hold in my mind, to be honest. I'm having a hard time with all of it. I will be honest.
The other observation that I make is that complexity science allows the melding of both the physical and the social sciences together in their analysis.
That's really important. That's one of the things that has completely altered my view of these systems, is that they are opening up not only individual minds, but they're opening up many disciplines that had never ever talked to each other before. And I think that's crucial if we're going to survive another 50 years.
Well, I certainly agree with you about the need for the conversation between these disciplines, which tend to be silos.
Mhm.
Or ivory towers.
Well, silo is a functional thing, and I was giving them a little credit.
There you go.
You can store up all your ideas, shovel them into there, so you have them later when you need them.
Yep. And you can make a lot of flapjacks too.
Norman, you're shaking your head. You got a comment, maybe?
No, I found the readings to be interesting, but totally confused as to where it takes one. The one example of the rioters in London or burglars in London showed me some purpose for the study.
Yeah, I think taking and generalizing that, the beauty of the new math is, which is the way I think of it, is that it is providing insights that were sitting there in plain sight, but just ignored. It's spectacular.
Well, I cannot, I was not able to determine any practicality either. Of the studies are very interesting, but when you come to the end of it, well, so now what?
Well, there was an interesting article that delved into the use in business of complexity science, and it made the distinction, and it was interesting to think about the difference between complicated and complex, and that the way you think about a complicated system is different than the way you think about a complex system. And if you think the complex system is just complicated, then you're going to come up with the wrong answers. Any comments?
What I think is most interesting, hello, Peyton, what I think is most interesting out of that aspect of it is the fact that some systems can be both complex and complicated depending on how you look at them. It's like the old elephant joke all over again. And I came up with a list of things that illustrate this ambiguity, which I think is fun. I've got it here somewhere. Let's see. Okay, 7 things that, if you analyze them, can be both complex and complicated, depending on how much information you provide about each thing. That's a car, a mosaic, a virus, a kaleidoscope, a horse, a crossword puzzle, and a human. And I think those 7 things do the spectrum of the difference between complex and complicated.
Now, can you use those 7 things to explain the difference to us civilians?
Okay. I'll before I do a specific example, I think one thing that helped me is I finally realized that the difference between a complex system and a complicated one is that a complex system, if you take it apart, you can't put it back together again. But a complicated system,
Okay.
you can take it apart and put it back together. So, for example, but with the added twist that once you've taken something apart, it may be so complex that you can't put it back together, even though when you took it apart, it was only complicated. And the example of that is the mosaic. That's why I was talking about. Is if you see a mosaic, it's clear what it is. it's clear what its function is. It's clear how it works, and it's clearly a mosaic is clearly more than just the colored pebbles that you use to put it together. But if you take it apart and just strewed all of the pebbles randomly and looked at them, looked at each individual pebble, you wouldn't necessarily have any idea
Mhm.
what it started out as. Compare
That's a
that
real
with
good
an
example.
But a
Okay.
mosaic is a piece of art, really, and that has nothing to do with the theory, really. It's just put together by someone who feels, that one color goes right with the next one, and then and another one. It's just a choice. That every pebble is a choice by a particular person, how it touches them. And I mean that's what's called art.
Right. Well, let me give you the other example to put it in contrast with mosaic. Maybe I wasn't clear. Take an automobile. If you took an automobile apart and you looked at the individual parts of the automobile, you would immediately see that it's a mechanical object intended to do something. And when you put it back together, there would be just one way to put it back together so that it worked. In contrast, a mosaic, if you take it apart, all you see is a bunch of pebbles, and you don't necessarily know that it was ever in a mosaic. You have no idea what it was intended for. It could have been used in a fish bowl as a bottom of a fish bowl. You just don't know. Unlike a set of automobile parts, where you would be able to know that it had a specific function of some sort. See what I mean?
Again, I think that's a good example.
Yeah,
And then you can play with it by uh, a hypothetical pile of a mosaic that is one color of pebbles with 100,000 different shapes. Okay,
It
and
sounds like
it's
the terrible jigsaw puzzle to
It
me.
does.
exactly, but it would be a topological
Right.
mosaic. It would be artistic because of its topological differences. If you took if you took that apart and strewed it around, that would clearly be a a uh, uh, a complex system. Okay,
Right. You
but
could put it back together. Yes.
yeah, okay, with me. So it these concepts, the reason they're confusing, I discovered, at least I think, in doing the reading, because I continued to get more and more puzzled and confused as I went through the reading. And it finally dawned on me when I thought about the mosaic example that it's confusing because it's intentionally confusing. It's impossible to draw a straight line between this is complex and this is complicated. That anytime you got more than one of anything, you get two pebbles together, it could be complex or it could be complicated. And you just have to play with the nature of it, which takes us back to the Stoics even. I mean, I hate to do that because I love the Stoics, but most people don't. But the Stoics had this same problem of of trying to analyze things that had more than one nature, and it drove them nuts. And I think they had the same problem we're having with the distinctions between uh, complex and complicated.
Keaton, what did you think of the readings?
Complicated. And when we talk about the mosaic, there's a lack of a defined relationship between the various pebbles.
Mhm.
So it can't be a complicated system. You have to have defined relationships.
Right. It could be, but it could be a mosaic could be complicated if all of the pebbles were square, for example.
Or in any other tiling patterns. There are lots of
Yeah,
tiling patterns.
yeah. You'd have to have something to define the relationship between the pebbles.
Right. And that's what I'm saying is that if you, depending on the adjectives you use to describe what it is you have, you can make it complex or complicated.
Yeah. But don't take this negatively, but I could not understand how this related to humanism.
Oh,
There are so many important topics along the lines of humanism, but I couldn't really understand what complex systems had to do with humanism. But maybe somebody can enlighten me. Sorry, I'm late to the party, as it were.
can I raise my hand on that one?
Okay, go ahead.
Unless Bob, do you want to take it or can I
No, you
run
go
with it?
ahead and I'll add on.
Okay. There's at least three ways that I see. By the way, Kate and I puzzled the same question when I saw the topic. So it's a hell of a good question. And I didn't really get the answer until I'd finished the reading. And the first one is that the analysis of complex versus complicated. And for example, you take a living thing and you separate it into its component parts and organs. You can't put it back together. And what's missing is life. Okay? You can't restore the life. So one of the things that these readings help me fully understand more clearly is the nature of life, the nature of reincarnation, the nature of the ancient concept of the soul. I mean, these are, and consciousness, the soul, life, these three are just some of the words humans have used for probably 100,000 years trying to describe what it is about these things that seem to be animated, self-animating. So to me, it relates to humanism in that it helps explain what's been bothering us all these centuries, and gives me another tool to do the surgery with.
Bob, do you have a comment on this?
Yes, I do actually. When I was looking at it, I was looking at it from the standpoint of interaction of human behavior with the world and with each other. And from that standpoint, I thought it was a interesting topic to explore because it is becoming more and more of a tool for comprehension of how we live, where we live, and who we are. And so that kind of defines what a humanist is in its interactions with each other. So that was the reason I brought it up. Besides that, it's a cutting edge issue that's going to become more and more prevalent in the future. Does that answer your question?
Yep.
And if I can follow up on that, one of the things I plan on doing now that I understand better, not perfectly, now that I understand the concept better, I'm going to be seeking out studies online that deal with social, historical, uh, social, political issues using these systems. That's one thing we didn't do with this month's reading. Didn't have a lot of opportunity to apply what we learned to gaining that understanding. So my plan is to see what I can find online that will help me see in practical action how these systems are helping us.
Yeah, the readings were basically to introduce you to the subject. And since the subject was so complex in itself by its nature, I didn't want to overwhelm everybody.
Right, exactly. It wouldn't have done any good because at least for me, I wouldn't have understood the studies that are using these systems because I didn't understand the system. So now that I have a grasp of the system, I think finding some of those studies will be helpful.
Sometime I'll have to get into a discussion with you guys about my multidisciplinary approach that I was part of in the 70s in developing a system of understanding for predictability based on behavior and man-machine relationship. That
Yeah, and this has been very controversial. I mean, I remember in the 70s, there were studies that were alleging to predict criminal behavior. Well, you can imagine the uproar that caused.
yeah.
And those studies were suppressed, but they then reemerged, surprisingly enough, or not surprising, in the whole business about building algorithms to determine parole criteria, which was based on, guess what, those earlier controversial studies on criminal behavior.
Of course, now we have a better understanding of entanglement and how two things can be the same. I appreciate it. The other folks didn't see this reading, but I appreciate it because it has will be part of another topic. But I appreciated your Zeno's paradox article that you sent me.
Yeah, that's really fun.
And I sent it on to Matt because he's going to be giving a talk, or Reverend Matt, because he's going to be giving a talk on quantum entanglement.
Very good.
So
I'm very curious how he presents quantum entanglement in a church service sermon, 15 to 20 minutes. That would be very interesting.
well, I did it with system science. He can do it with entanglement. I was very close to going down one of those paths. So,
Yeah. Entanglement still remains a major mystery in my mind. It's beginning to glow a little bit, but it hasn't burst into flame yet. So I'm working on that.
did you find that this topic is so overwhelming you don't have anything really to say about it?
I can't really get my arms around it. It's something I have to spend a lot more time thinking about, I think.
Well, let's see if we can make it a little more simpler to explain. You understand systems, right?
Mhm.
Okay. And you understand the multiplicity of systems.
Mhm.
And you understand that the multiplicity of systems can interact with each other.
Right.
And that this interaction crosses both the physical nature and the social nature of
Mhm.
mankind. And that the whole idea of this complexity science is to meld the two together to try and develop some sort of degree of predictability, or at least comprehension or understanding.
Yeah, I think that's where I am. I mean, I can kind of
You get to that
see-
point and then you're stuck.
Yes, theoretically, I'm just having a hard time. I guess something like you said, Keaton, figuring out how this fits into humanism.
I kind of hate the idea that humanism will be brought back to a system of some kind. I mean, it is much more than that to me. It's an attitude.
Well, it's not so much as system. You don't think about it linear, but you think about it interactional between let's say nature and all the rules of nature, and man and all the rules of man and how we think. the social sciences aspects, whether it be psychology, anthropology, sociology, etc., then that interaction is almost like, well, that's how we act in the real world, with both forces applying itself to our behaviors and our way of thinking.
Yeah, I'm surprised at the adverse reaction to complex systems theory, because that actually adds a lot more ambiguity to things human than a linear system does. A linear system
Right, right.
is
Too
thou
predictable
shalt,
for humans.
right. Whereas, see, with a linear system, you can have a 10 commandments and that's it. All of your complexities are removed because it's directly linear. Whereas with complex system analysis, there are no 10 commandments, because each one of those commandments is changing constantly because of changes not only within each of the commandments, but all things that are emerging from outside those 10 commandments. It makes not just the universe, but life itself uh, amazingly more ambiguous and fun to play with. So I would think a humanist would be all in favor of complex systems theory.
As long as it's fun.
Yeah, I think as long as it's interesting and all that, but to make it a way of life and say, well, like, I'm doing this because of such and such theory, that just doesn't work for me.
Well, what do you have against a theory as opposed to whatever your life force is? How do you define your life force or your life energy? What guides you if it's not the fact that the universe is complex? I'm curious.
Yeah. Well, I'll grant that the universe is very complex, and as we are part of that, and we are very complex in and of ourselves. But to try and break it down to something that you can explain all the parts of it and say, well, this man or woman is doing such and such or saying such and such because of this and that, and it has to fit in a certain pattern. I don't know. I've never thought of doing that, and
No, but that's not
it
what
just
complex theory says. Complex theory says the exact opposite. You can't just take the parts of something and determine what it is, where it is, why it is, because everything is interacting with everything else so quickly that you can't do a straight line going from A to Z and come up with a conclusion. It's on your side. Complex systems theory is on your side of the universe squarely.
well, that's nice. I'm not quite sure where it helps me.
There's two things in looking at it. If you look at it from a timeline, there's two things that happens. One is that if you retrograde what's happening, then there's a deterministic model saying this happened because, and it becomes explainable through complex theory. If you look at the future, then you look at the possibility of unintended consequences, which we haven't really talked about, and how that occurs, and if there's any way of predicting what those unintended consequences will be due to probabilistic modeling.
Exactly, and that's what we do
Algorithms can be wrong.
that's what we do every day of our life is we take a complex, ambiguous, who the hell knows kind of universe and model it to try and make a guess as to what our next move should be. I know I go through that every morning when I wake up. Am I going to get up now or in 10 minutes?
That's the
Well, I
brain's
be awake in the
job.
morning.
And that's the brain's job. The brain is always looking and trying to predict what comes next, because if it knows what's next, it's easier to deal with it.
And not to get too philosophical, but the whole idea of what happens, that nothing is an accident, goes back to Aristotle. And he said that nothing is an accident. You can always go and figure out what caused the causality of any action.
And again, if you go in the Hindu side, they were saying that kind of stuff a couple of thousand years before Aristotle. They just didn't have as good a press agents.
Well,
Yeah,
and it didn't
Socrates
speak
was pretty
Greek.
good.
Yeah, it's the linear approach to life and understanding and the universe and morality and all of that is the simple way, and that's why I think it's the most popular. In Asian philosophy, it's a little fuzzier than that right from the very beginning,
Right.
and Westerners, that's why Westerners have a problem with it.
Yeah.
Is it's too fuzzy for us.
And,
So,
I'm sorry, go ahead.
no, I'm done.
I was going to say one example of what you're talking about for me, linear thinking versus some other kind of thinking, is an experience that I have had many times in meditation, where something that was going on, maybe usually in the background of my mind, some real complicated subject that I was struggling with, suddenly the whole thing became clear, not one piece of it, but the whole thing becomes clear. And it's not something that is a linear process. Anyway.
Yeah, for like life itself.
Right, like life itself, exactly.
It's one of the great joys of life when that happens.
Indeed.
Yeah, those wonderful aha moments.
I miss that.
So it's like those wonderful aha moments.
Yes.
Oh yeah.
Yeah.
Oh
And they
yeah.
don't come from linear thinking.
No, they do not.
Nope. Never do. It's
That's
fuzzy
why
is
for
better.
me, sometimes when I have a problem, the best thing to do instead of working on the problem is go pull weeds.
Well, you're talking about the kind that grow up in your garden, right?
No, the garden weeds, that's right.
Okay.
Not the buds on top.
Okay.
You look like you were going to say something.
Well, I take a siesta. That's what I do. And then when I get up from my siesta, I've figured out a lot of things,
Mm-hmm.
like where my earbuds. That's my problem resolution time.
Uh-huh. So again, part of it is that we're talking about is the same, is to resolve the problem, you put it down and then come back to it. When I feel like when I do that, when I pick it up again, it gives it a chance to put it in a new order.
Something new has emerged out of the universe.
That's right.
Yep.
Well, if nothing else, studying complex systems has helped me to understand why nobody can predict the weather. There's variables in the weather and other things that happen in our lives that, it makes it impossible to predict when there's going to be a hurricane or when it's going to rain. As simple as that. It's just so simple. And as they it's never going to happen that every single variable is the same as last time. There's always one variable that's different, causing maybe major changes in the weather or whatever system you're looking at.
Yeah, the problem is not recognizing the variables.
Well,
Yeah.
not knowing how
Yes.
they go together and not knowing which you're going to change or when or how much or what impact a variable is going to have on another variable or a dozen other variables. And what impact are those changes going to have? Lots or little? It's weird.
Hence the problem with an open system versus a closed system.
Right.
I think it's safe to say that this month's topic has been the greatest brain twister of them all. Bob, you're going to have a hard time coming up with a bigger brain buster. And if we took a secret vote, there might be a slight majority of something a little easier next month, and then hit us with a really good brain buster.
You want us to have a month's rest, rest and recuperation.
Yeah.
I do have another topic, and all the research is now done on it.
Okay.
Yeah,
So you're ready for us.
I'm ready for you, and it's a little more straight line than complexity systems.
Excellent. See, that's what I think your crew needs is a little R&R. Because this one, I tell you, Hurricane City, really fun, but whoa.
Yeah, I know, and it's hard to go through the math on that. And in fact, for me, it's incomprehensible, the math,
Right.
outside of just the basic understanding of statistics, probabilistic determinism, heuristic modeling. That's as far as I get. And the problem is, of course, in an open system, who knows where the next variable will be that we've missed.
Mm-hmm.
Well, and then the ultimate question, is the universe an open system or a closed system?
Well, I was going to ask that. So you beat me to it.
Well, there's two answers to that. It could well be a closed system.
Yes and no, huh? Okay.
Yes and no. It could be a closed system, but for our understanding, it's an open system because we don't know what the hell we're talking about.
If it was Hindu or Jain, they wouldn't necessarily say yes or no. They might say yes and no.
And no. I think that's a more appropriate answer. And it's the answer that
even better, we don't know.
Yeah, we don't know.
Right.
You see, if the universe is infinite, then it's a closed system. If the universe is not infinite, then what's on the other side?
Yeah. Or let's go down the wormhole of a black hole and see what comes out the other side.
Exactly. You got it. Yeah.
To you, Bob.
Yeah. So any comments on this
Well,
before we move on?
so what's the use of it all?
Pardon?
What's the use of asking and torturing your brain with these questions?
What's the use?
Yeah.
It's fun.
Okay. All
Expanding
right.
our knowledge.
That's a good answer.
Right, that's the best
There's
answer.
two answers to that. One is, besides being fun, it's expanding our knowledge and also self perspective, looking at ourselves and seeing who we are.
And for old people, just in case there are any on the call, it turns out one of the things that keeps you young and alive is stretching your brain.
All
And
right.
having discussions.
Yeah. No, that's from here.
That's why I practice my French every week. Stretch
Very good.
I
We
think
have
that's
a
a little
meeting
easier.
where we
It's a
talk
little
for an hour.
easier than contemplating this. Sorry.
So you talk for an hour in French?
An hour and a half, actually. Yeah.
Wow.
Yeah.
I usually talk in French when I hit my thumb with a hammer.
Which was your preferred word?
I'm just kidding.
Okay, final comments before I go into next month's topic.
Okay.
So, John, anything to say?
Well, I did, I think it's interesting and entertaining to be sure, but I wonder how much we can contribute by or how much these theories contribute to the betterment of life of people. And there's a lot of misery going on, and I would like to to talk about things more practical.
Richard?
Well, I like to think about things that I can't think about, so it's good.
Joyce?
So for me, this actually is very similar to what I think, James, you mentioned earlier about Asimov, and the statistical modeling of behavior, which took an enormous world computing system, and I'm not sure what the benefit was of it. So I think I kind of align with you on that, John. It's a very big thing to think about, and I'm not sure how it helps me in my interactions with people in involvement in society. So I guess maybe I'm more of a hands-on sort of person.
Keaton?
No, that's fine with me.
Norman?
Well, great introduction. I complex systems is something that I'd not even heard of, and developing a small understanding and the tremendous amount of data that has to go into analyzing complex systems. Very interesting.
And I want to thank Jim for his tutoring as we went along today.
Yeah, go along with that.
Well,
James?
thank you. And well, the world needs both the people who are hands-on, dealing practically with the immediate problems, and it also needs ivory tower people, and governors, governments, NGOs who are trying to find out what the problems are and how to prioritize them. And I use as an example of this Albert Schweitzer, Dr. Albert Schweitzer, uh, who early in African colonial history brought Western medicine to a large part of Africa and saved thousands of lives. And he was extremely hands-on. The problem is what he didn't realize is that by saving all those lives, he allowed the local population to double, triple, and quadruple. And so 50 years after he had performed his medical miracle, twice the number of people were starving to death in that same region. So we clearly need hands-on people, but we also need people who are looking to see what the consequences of each individual charitable act is on the whole, the gestalt. And that's why I find this kind of study interesting.
Yeah, I can see.
And two observations, John, for you and others. One is the concept of the big data dump and what do you do with big data? And the other is that using the modeling and what we learned from complexity science on problems of migration, famine, drought, and other very, very complex issues in the world, and how it can maybe help us in understanding and solve our problems by looking at the patterns that emerged that we didn't know were there.
And I've been
Yeah,
a guy who's
nonlinear
done a lot.
thinking.
I've done a lot of analysis in my life, and having another analytical tool to me seems wonderful.
Now, next month's topic, AI and the future of warfare.
Okay. Wait for the bombs.
Not only wait for the bombs, but what's actually occurring. Like, for instance, I kind of look at what's happening in Ukraine and in Israel
Mm-hmm.
and their techniques as to what was happening in Spain during the Civil War. It was a testing ground of new techniques and new technologies
Sure.
and strategies.
Also, U.S. and North Africa, while we were developing our techniques so we could invade Europe.
Yeah. And so we're going to look at that and also the ethics of autonomous warfare
Oh, boy.
and history.
Okay.
A smaller topic, you
I'm
said.
sure, I'm very glad you're giving us
It
a
is a
break
smaller
next month.
topic.
Yeah, I'm glad. I'm
It's
glad that
defined.
you
Yeah.
don't take on more than one world.
Anyway, I thank you for all joining.
Thank you.
And thank you for organizing it and doing all the homework that gives us the reading list.
And this
Thanks,
has
Bob.
always been a pleasure to talk with you all. I look forward to this monthly gathering very, very much each month.
Absolutely.
Thanks for all your work, Bob.
Yep.
Thank you.
Okay.
I'll see you later.
Adios. Adios,
Adios,
amigos.
everyone.
Adios, amigos.
Okay.